Hi everyone. You may know 3 different ways in which people talk about the derivative. Some people say that the derivative is the slope of the tangent line. Others say that the derivative is the limit of a certain quotient. People who like physics like to say that the derivative is the instantaneous rate of change. Out of these 3 different ways of talking about the derivative, which one is the real definition of the derivative? The real definition is the middle one. The derivative is the limit of a certain quotient. The other 2 are ways of interpreting the derivative. To understand this, I have a problem for us to complete. If you would like to try this problem on your own first, download these notes using the link in the video description. We are given the function x squared plus 2x plus 1, and we must compute the derivative of this function at 1 using the limit definition. So I write the limit as h goes to 0 of f of 1 plus h minus f of 1 divided by h. This is what the limit definition says when it comes to taking the derivative at x equal to 1. I can't simply plug in h equal to 0 because then I will get an expression of the form 0 divided by 0. Instead, I plug in 1 plus h to the function and 1 to the function, and I get the limit as h goes to 0 of 1 plus h squared plus 2 1 plus h plus 1. This is what I get when I plug in 1 plus h to the formula. Then I will plug in 1 and I get minus 1 squared plus 2 times 1 plus 1. Everything gets divided by h. To compute this limit, I will simplify the numerator. First, I multiply out the first parentheses. When I square it, I get 1 plus 2h plus h squared. Then I multiply 2 by the 2 terms inside of the second parentheses, and I get plus 2 plus 2h plus 1 outside of the parentheses. Finally, I distribute the minus to every term inside of the third parentheses, and I get minus 1 minus 2 minus 1. Everything divided by h. A few things cancel. 1 and negative 1 go away. 2 and negative 2 go away. 1 and negative 1 go away. In the numerator, I also have 2h and 2h. That gives me 4h plus h squared in the numerator. So I get the limit as h goes to 0 of 4h plus h squared divided by h. This allows me to factor h from 2 terms in the numerator, and I get the limit as h goes to 0 of h 4 plus h divided by h. Then I divide out h, which leaves me with the limit as h goes to 0 of 4 plus h. Plugging in 0 for h to this expression gives me 4. The derivative of the function f at 1 is 4. What is the meaning of that number? We can understand this number in 2 different ways, using geometry and using physics. Let's start with geometry. We must interpret f prime of 1 as the slope of the tangent line, and then say what f prime of 1 tells us about the graph of f at x equal to 1. This number 4 is the slope of the tangent line to the graph of f at x equal to 1. So, if this is a function given to us f, and this is a point corresponding to x equal to 1, at that point there is a tangent line with the slope of 4. What is the meaning of this number? We can say that slope of 4 indicates that the tangent line is increasing, which means that the original function also increases near x equal to 1. What's more, it increases quite fast. 4 is a rather large number. To understand this number 4, to understand the meaning of the derivative using physics, we must assign some meaning to the formula of the function. So this time, we will assume that the function f of x represents the height of a toy space rocket over time, where the height is given in feet and the time in seconds. We must now interpret f prime of 1 as the instantaneous rate of change. In our case, f prime of 1 was 4, which means that the instantaneous rate of change of the position function, in other words, instantaneous rate of change of f of x, is 4. Because f of x is the position function, the instantaneous rate of change of the position function has a different name. It's called instantaneous velocity. This means that the rocket was going up with the instantaneous velocity of 4 feet per second. And it was going up with that instantaneous velocity at the first second, exactly the moment of the first second.